Have you ever really thought about it? What would happen if humanity just vanished? It's a classic sci-fi question, right? But the actual answer, what we'd really leave behind, is way more fascinating and honestly, a lot weirder than you'd think. So let's explore what that thousand-year echo would actually sound like.
Okay, so picture it. We're all gone. What's the biggest, most dangerous time bomb we'd leave ticking away? I bet for most of us, the same image immediately pops into our heads, an idea that's been drilled into us by movies for decades.
Yep, nuclear power plants. The fear is that without us at the controls, they'd just go haywire, spiral out of control, and trigger some kind of global catastrophe. But, is that what would really happen?
Well, not exactly. You see, modern reactors are built with some incredible fail-safes. Without people around, the computers would almost instantly know something's wrong. They'd automatically trigger what's known as a scram, which is basically just a fancy term for an emergency shutdown. The control rods slam down, the fission reaction stops, and the whole thing happens in just hours, maybe days, with backup generators keeping the cooling systems running.
And here's the most important part. A mushroom cloud-style explosion? Physically impossible. The fuel just isn't enriched enough for that. Now, a meltdown isn't totally off the table if all the cooling systems eventually gave out, but it wouldn't be this huge, violent blast. It'd be a slow, gradual ooze, contained by layers and layers of safety structures. Our nuclear ghosts are a lot quieter than we've been led to believe.
So if it's not the nuclear plants, then what is the real long-term danger we're leaving behind? Turns out, the answer is something way more common. Something you see every single day. It's this. Steel-reinforced concrete. It's the literal foundation of our entire modern world, our skyscrapers, our bridges, our dams. And it has this hidden weakness, a kind of slow-acting poison that's already doing its work.
And that weakness has a name: carbonation. To put it simply, carbon dioxide from the air we breathe slowly seeps into the concrete. It is porous, after all. And that CO2 kicks off a chemical reaction that changes the concrete from the inside out, stripping away its most important protective feature.
So here's how that works. Brand new concrete is super alkaline, which creates this amazing protective force field around the steel rebar inside it, stopping it from rusting. But as that wave of carbonation pushes deeper and deeper, it neutralizes the alkalinity. The shield fails, and suddenly, water and oxygen can get to the steel, and the skeleton of our civilization starts to rust from within.
And listen, this isn't some distant, post-apocalyptic problem. It is happening right now. This quote just says it all, doesn't it? The stuff we built to last for generations is already failing, and this relentless chemical attack is a big reason why. But it gets even crazier. The more CO2 we pump into the atmosphere, the faster this whole carbonation thing happens. Projections show that the structures we're building today could have their lifespans cut short by 15, maybe even 20 years. We're literally changing the chemistry of the sky in a way that dissolves the very world we stand on. So as our concrete world starts to crumble, something else starts to happen. Without us constantly pushing it back, nature returns. But how it returns really depends on where in the world you are. In a wet place, say Washington, D.C., the takeover would be fast and green. Water speeds up the decay, and you'd have plants literally ripping our buildings apart from the roots up. But in a dry climate like Phoenix, with no one there to pump in water, the city would just slowly, quietly surrender back to the desert. Its buildings would be eerily preserved for way, way longer. Okay, so you've got crumbling concrete on one hand and nature creeping back in on the other. But there's a third story, a much bigger one that connects everything. And this is the one legacy that is truly, deeply irreversible. It's written in the atmosphere itself.
This graph, this right here, is from a landmark scientific paper, and it shows something absolutely staggering. It shows that even if every single human CO2 emission on Earth stopped tomorrow, the CO2 levels in the air wouldn't just go back to normal. Not in 100 years, not even in 1,000.
And that brings us to this key number, 40%. 1,000 years from now, roughly 40% of the extra CO2 we've added to the atmosphere will still be up there. It gets absorbed by the deep ocean so slowly that it creates this atmospheric echo that rings on for millennia. And because that CO2 lingers, guess what? So does the heat. The warming we've caused is effectively permanent on any timescale we can comprehend.
The oceans have soaked up so much heat, they basically become this giant radiator for the planet, slowly releasing that warmth and keeping the thermostat turned up for at least 1,000 years.
So what does a permanently warmer world actually look like? Well, it means profound, irreversible consequences. We're talking about permanent shifts in rainfall, creating droughts in places like the American Southwest and Southern Europe that would look a lot like the Dust Bowl. And of course, the slow, relentless rise of the seas.
And to be crystal clear, the sea level rise you see on this chart, that's just from thermal expansion. That's the water itself physically getting bigger as it gets warmer. This is the absolute, most conservative, best-case scenario. It doesn't even factor in a single drop of water from melting ice sheets, which could add meters more. This is an unavoidable geographical reshaping of our planet.
So in the end, our most dangerous legacy isn't some loud explosion. It's a slow, quiet chemical reaction happening all around us, on a global scale. It's written in the sky above our heads and in the concrete beneath our feet. And it leaves us with one heck of a question. Knowing our echo will last for 1,000 years, how do we start building a world today that's worthy of that long of a memory?